Good evening, friends. Welcome to Eason Academy. We are into embedded system programming. On embedded system programming, we are discussing about microcontrollers. And today's session is a third session. Today, we are going to discuss about timer and counter. Okay, so we always have some issues. We wanted to go in details always. That does not work. Okay, first we need to understand the top bird. We call it a bird view. First, let us understand what the timer and counter does. And before that, let us review the last two sessions, what we discussed. Okay, so what we discussed in the first session was, what is microcontrollers? It's quite simple. What is microcontroller is nothing but it has few major components. One is microprocessor plus ROM to execute your software plus RAM plus output plus input. Then some more common. We will discuss that next. So this is what first class what we discussed was only this four. And together, if you see that whole thing, we have only two components. One is output. That is nothing but whatever you give here 8-bit. See, understand, all microprocessor are minimum 8-bit. There's nothing called 1-bit microprocessor. There is nothing called 1-bit microprocessor. This is not there. The minimum is 8-bit. That's why in C, Dennis Ritchie started with CHAR, which is 8-bit. So we don't have a thing. Or if you don't have a 8, you have then 16 or 32 or 64. Okay. Right now, let us not worry. We discuss about only. That means there are 8 wires to connect all the people. So they all communicate with these 8 wires, not one wire. Please understand. So this microprocessor talking to everyone with the help of how many wires? 8 wires. That's it. And you select each device by giving your address. And you can do write or read. That's all. That's all. Totally. See, you'll be very surprised. The whole hardware is very, very, very simple. Okay. Don't get confused too much. The biggest problem with you is that the confusion. Please do not get confused. They are very simple. And I have explained that how this address is generated. Write a small program. Instead of X, you put a star. Only that. We will discuss this later in our pointer session. Right now, don't worry. Now you put X is equal to any address, 1000. Star X equal to 25. Now what happened? It gives 1000 here. And it gives write 1, read because you are writing. And the data 25 goes here. That is 25 means 0, 0, 0, 1, 16 plus 8, 24 plus 1, 25. 1, 2, 4, 8, 16. So if I say this is a D data that has 8 wires, that means D0 to D7, 8 wires. The 0 goes here, 0 goes here, 0, 1, 1, 0, 0, 1. 1 means 5 volt, 0 means 0 volt. That's all. All our voltage. There's nothing called 1 or 0. Please understand. There is nothing called 1. It's all only for you. Actually, all of them are voltage only. That we will discuss in depth on. Right now, don't worry on in depth. In depth, we will discuss it on our digital electronic session. Now you will know that why you have to know this. So this is the best part method. First, you learn this microprocessor and microcontroller without knowing about other things. Then learn digital electronics. Then once again attend this session, next batch. Then you will be very good clarity. This is called a cycle. First understand top level, then understand go in, then go in. This way you will be able to understand this very good. Right now, you'll be having lots of doubts. Lots and lots of doubts. Don't worry. We'll clarify that. That's the way the whole system is designed. So this is called microcontrollers. Microcontrollers. What we did initial days was, we put, when I was studying in college in 1980s, we put everything as a separate chip. All are so many chips. One is called microprocessor 8085. Other one is called ROM 2764. One is RAM 6264. Output 74373. These are all numbers. And input 74125. Like that. Every IC is there. I've given even a number. We buy that, we connect them. We make a system. But to make your life easier, they integrate everything. Like how a smartphone came. We have a TV, we have a camera, we have a phone. Okay, everything has been recorded, voice recorded. Okay, video recorded. All these things have been built into one phone. Am I right? That is what the technology. Same way here, the technology is this now. Now then what happened? This is the trick. This is the trick happened. Now you write a program in your PC and you send it to the ROM. That we are going to discuss on next session. How you write a program in a PC, how it is going to ROM. We are going to discuss on next session. That's a very critical, because that is a doubt you always having it. So you can change the code always. But what people did was, let us say I have a company. My company, what I did was, I have got some good method how to talk to the motor. How to talk to the motor. That means that, like me, I'm a driver. I told you already. As a driver, I know driving. I have learned driving for so many years. So if you tell me that from Chennai to Bangalore, I drive the car. You do not have to. I need not have to waste my time. That's all we discuss. Now, as a microcontroller, this guy is having same thing. A microprocessor, a ROM, a RAM, everything. This is another microcontroller. But what I have done is, I have put a code here which will control only the motor, nothing. You cannot connect anything else. Whereas this microcontroller can connect anything, monitor, everything. But this microcontroller, you can connect only motor. The software inside is controlling only motor, but it will take the input from you. You can give the input. So please understand the difference between this and this. This microcontroller could do for any generic purpose. You can change the code in the ROM from the PC. So you can make the microcontroller to work as you wish, anything. But whereas this microcontroller is doing a specific job. There are two human beings. One is a generic one, is a manager who manage everybody. But whereas this guy is a driver, he does only driving. Like that here, both of them are having a brain. Understand? Both of them are having a brain. Like that here, both the systems are having microprocessor, ROM, everything. No difference. The only difference is this guy is doing specific. This guy is doing generic. But to differentiate that, they call the specific one as a controller. Please understand difference between controller and microcontroller. Microcontroller does generic task, whereas controller does specific task. That's it. Only one task. So what people did was, they did like me. So many companies design, like Eastern Academy. So many companies design controllers. One guy said, I will control the keyboard. Another company said, I control mouse. Another company said, I control hard disk. Another controller said, I monitor. Another controller said, I say LCD display. You have so many controllers. These are all called controllers. We call them keyboard controller, mouse controller, hard disk controller, monitor controller, or display controller, LCD controller. What these guys did was, slowly, they have started putting all these things inside. Still they start calling microcontroller. So microcontroller has ROM, RAM, output, input, and controllers. This is the biggest transformation in the technology. They put everything inside a single silicon, small piece, maybe about 2-3 mm to 2-3 mm. That's it. So small, and they put it in a package which you can use it. So this is silicon, and there will be a connection, and they will close it in the top. They close the top such a way that they call this as a package. For example, you buy an item from Amazon, you may be ordering some small RAM drive, pen drive, or SD card. When it comes a big package, because nobody can handle such a small part like that here. The silicon, you cannot handle it. That's why they put it in a package. Actually, silicon is 1%, packaging is 99%. That's a trick here. See here. So please understand the difference between controller and microcontroller. Both are same. Both you can design your own controller. I'll tell you later. Once you started completing the embedded system programming, I will tell you how to design your own controller. If you have done that own controller, then you are the man. Afterwards, you can claim anywhere that I'm a great guy. But to come to that level, you need to have a lot of things. I'll tell you. This is important. I'll never go back from my C programming. Please. Unless you are good on this, nothing can work. All these things, the base is only this. So if the base is not strong, you cannot build a big building. To construct a big building, your base of C programming is to be strong. So this is what we discussed in the last session. First session, we discussed microcontroller introduction. The second session, we discussed about controllers. Today, we discuss about a specific controller. Then we will know that how it is doing. Okay. Now let us assume I have a microprocessor. I have a microprocessor. Let us assume that I have a before microprocessor. Let us take myself. Let us say I am Balaji. I am Balaji. I have a switch. I have a switch. And I have a bulb. Understand? I have a bulb. So if you on the switch, bulb is going to glow. If you off the switch, bulb is going to off. Understand? Let us assume that I want to make the bulb on and off for every 1 second or every 1 minute. Every 1 minute. Every 1 minute, I want to make the bulb on and off. So 1 minute on, 1 minute off. So it just blinking. It's just blinking. 1 minute on, 1 minute off. How do I do that? Quite simple. Think about, see, please. I'm trying to explain as simple as possible because this is what exactly your embedded system. Nothing more than that. There's nothing to worry or confused on this embedded system. If you come with a very plain mind, you will master it at shortest time. Okay. So now, how will I do that? I will on the switch. Okay, it's on. Then I have to give a delay of 1 minute. How do I give a delay? I don't have a watch. I don't have a clock, anything in the room. How do I do that? I'll start counting 1, 2, 3, 4, like that. Am I right? I'll start counting 1, 2, 3, 4, 5, like that. The moment it becomes 60, I'll off. Then I'll start counting 1, 2, 3. Then I'll off. Am I right? This is quite simple. I do count. Okay. So I know that 1, 2, 3, like that. I give a small gap because I know that that's a 1 second gap. That may not be accurate. That may not be accurate. But here also we do same thing. What? In our system. In our system, let us assume that I have a microprocessor I have a output. That guy address is 8,000, assuming. Now, what I do here is quite simple. I write a simple program and I connected a bulb on the first pin, D0. I connect the first pin, I connect the bulb. Forget about the LED and everything, we'll see that first bulb. Now, when I say character star X, out, let us give out. That's a good name. I'll say out is equal to 0x 8,000. Understand? Then you say star out equal to 0, 1. Say 1. 1 means 0, 0, 0, 0, 0, 0, 0, 1. So the LED is going to be on. Done now. I could able to on it. If you make star out is equal to 0, that is going to off. So if this is equivalent to I on the switch and off the switch immediately. The other guy may not even notice that it is on. Such a shortest time I made it off. So what I have done here is I did a very simple thing here. I did a thing for, while 1. While 1. That means that the while 1 means I'll be always in the loop. I will never get out of the loop. That's called meaning called while 1. The last yesterday's session, we discussed about while 1. What it does was quite simple, and it is a simple loop, infinite loop. Now I do here star out equal to 1. I on the LED. Then I say for, I say int I. I is equal to 0. Okay, let me write this here. I is equal to 0. Yes, because if you don't give it, how that guy will take it? If this case address is 8,000, let's say I have to give you some work. I have to call your name. Am I right? If I don't call your name, if somebody has asked that, is it necessary to give address to on the LED? Without address, how do you know that which LED? For example, let us assume that. Let us assume that I have one more output. That is 8,001. I connected a motor. I connected a motor. Now you have to decide here whether I want to on the LED or on the motor. So if you say 8,000, it will on the LED. If you say 8,001, I will on the motor. So everybody is having, you can have n number of output like that. I can have one more output. N number of outputs. Okay. Not one. You can have anything. You can control n number of LEDs, n number of motors. So now I write a program for I is equal to 0, I less than 10,000, I plus plus, semicolon. I don't do anything. See, I don't do any work now. That's all yesterday I explained the for loop. I'm doing just counting. 1, 2, 3. The moment it becomes 10,000, it will come out. I put star out is equal to 0. Then for I is equal to 0, I less than 10,000, I plus plus. See here, this is a quite simple program. This program will make the LED, which is connected on this port, on this address 8,000, on pin 1, a bulb. Suppose you connected a bulb on pin 8, pin 1 to 8 or 0 to 7, all the same, 0 to 7, Q0 to Q7. Then you can say here, instead of 1, you should say 128. 0, this is 0. Understand now? You can able to make this very, see, this slowly will increase. Everything is based on your programming skill. Okay, your programming skill. That the more you know this programming, the more you become the controlling person. That's why I always say that first to master this, then come here. I know that I've traveled with the students for last 30, 40 years. The problem is Everybody doing a one mistake. Most of the ECE students doing a one mistake. They try to learn C from embedded system programming. They first buy a microcontroller board. The moment I wanted, they out of curiosity, go and buy a microcontroller board. Then write a code and then start learning C. That's not the right method. In this method, after some few days, you lose the interest and they say that, oh, embedded is difficult. But that is not right. You have to do other way. You have to first master C programming, then get into, then you should do on simulation. Never buy a board. Do it on simulation. Make sure that you have a good logic. Don't waste money. You have a good logic. Then get into the hardware. This is the third step. So you do always reverse because you are curiosity. You have been told so many years always electronics means hardware. So you think that unless I control a LED, I control something connected through wires, I'm not an electronic engineer. Who told that? Nobody. Today, if you go and tell a companies, I'm a ECE student, I know C programming, they'll give you a job. You might not even, you say that you're not even touched the microcontroller board, you will get a job. Please, let me be honest. It's the truth, which we have recruited a lot of people who have not even touched microcontroller board, but they are wonderful embedded engineers. You'll be surprised. Okay. So please, lot of myths. You have to remove all the myths. All the myth has to be removed to get into the next level of you understand 2022. You are not in 80s or 90s. You are in 2022. Please understand. So this is the way it works. Now, what you do here is this is a thing. When this microprocessor is doing this work, just think a minute. This is 8000, and that pin is connected to LED bulb. And you are on and off the bulb. Now the only problem here is this. What you are doing here, you are in while loop. Like when you do the control, think of it. When you individually control the bulb every 1 minute, you are not doing anything. You are wasting your time. You on the bulb, then count 1, 2, 3 up to 60, then off the bulb. You are wasting your time. But here also, in this case also, microprocessor is wasting the time, which they don't want. They thought, how do I avoid it? Like in your case, you bring a watch or clock, wall clock. Wall clock or watch. Okay, what you do is you on the LED, or the bulb, you on the bulb. And to have a precision time, you will watch the clock after some time. But you will do some work, then go and watch the clock. So you will keep on watching the watch or clock to make sure that the 1 minute is over. That's a method we used initial days. Then came a nice method. What happened? Your clock had a thing called alarm. You set the alarm for 1 minute. What you do here is you push the button here. You push a button. The moment you push a button, this guy start counting for 1 minute. The moment 1 minute over, this guy will give you the alarm. The moment alarm is over, you will stop. Then you will do some activities. After that, you will go once again, start the alarm. You understand this? This is a very clear thing. In this case, you do not waste your time. So there are three possibilities. You do that. First possibility is that you control the switch by yourself. Counting. That is this. Your microprocessor is writing a program and counting. Then what you have done is you give this to the watch or clock, whatever it is. But the problem is that gate don't have alarm. So you have to go and see now and then whether the time is over or not. But the moment the time is over, you will go and control it. So use clock or watch. Both the same. And polling. This we call polling. Polling means you go and see that. You go and see. You repeatedly go and see that, whether it's the time is over or not. That means that you'll be doing your work and watch the clock on the wall. Oh, it's over. Then you go on it. And third method is very simple. You use the watch or clock and you set 1 minute. You know that. You set the time. Whether it's a 1 minute or 2 minutes, everything, you will set it to the clock. Am I right? There's a small, what do you call it? Knob will be there. Using the knob, you'll be setting it at the time. Now, this guy will set the time for 1 minute. Use clock or watch. And this is called alarm. What the alarm does, you just think about what alarm does. You do some activity, but suddenly when the alarm comes, let us say you do some activity on a paper, you are doing the 10th activity. When you do 10th activity, if there's alarm comes, you stop here. You stop on the 10th one, you put a some signal, some symbol, or if you are reading a book, you will put a page mark, then close the book. Then you will attend to the alarm. If somebody knocks the door, you'll say, what do you want? Then after you have done the work for him, then you will come back from this page, 11th page. You will come back from the 11th page. That's why they call this alarm is called interrupt. What is the name called? It's called interrupt. Okay. So there are 3 methods available when you are trying to deal with the outside. One is you can do it, or you can use the controller, but with polling, without interrupt. And third one is you can do with interrupt. Now we do same thing in microcontroller. Okay, now the same thing here. Now I have a microcontroller. Okay, this microcontroller is having a microprocessor. And this has out. Forget about ROM, RAM. Everything is there. All our programs are executed by RAM, and all our variables are stored in RAM, because you cannot write in ROM. This is read-only memory. This is read-write memory, or we call RAM. The RAM is called not random access memory. It's called read-write memory. This is read-only memory. This is non-volatile. This is volatile. The moment you switch off the give a power, remove the power, this guy will lose everything, but this guy will keep it. That's why it's called non-volatile. That we will discuss on the memory session, how exactly that is stored. Okay, I've partly explained on the previous classes, the microprocessor classes. I will explain this more deep in our digital electronics class. I have a full session called memory. I'll explain what is ROM, what is RAM, and everything. Now this output, see here, this output. Now I connected a bulb. Now what I have done here is, this case address is 8000. That's what this. Then I control 0x pins hexadecimal. Forget it. Now I put, let me start one itself. Fine. So I put the bulb, this bulb on and off. This is what exactly this. So if you buy a microcontroller, if you want to do this, this is the first exercise I'll give you. This is the first exercise I'll give you, that not first one. First one will be on the LED, off the LED. Then we'll start getting into the loops. We'll say that on blink the LED. Once you master this, then we can go that. We can change the time. If you change the time, you'll do that. Then what happened? They had a controller inside, like a watch. Like a watch, they have a controller. Here they call timer. Don't worry about what is inside. See, when you are buying a clock or watch, you don't worry. The same thing here. You are a embedded system programming person. Please understand. So you buy a clock or watch, this is a controller, this has his own brain, everything. Now you tell him You tell him to the data bus. This guy could be address is 9,000. See, this guy address should be 9,000. Please understand. Okay, not 8,000. Now, what I do here is this. Everything is here. Out is equal to 0x 8,000. That's fine. That is same. Now, what I'm doing here is one more I'm defining. Start timer. Understood? Now I'll say that this address called timer is having address called 0x90. See, please don't get confused with these numbers. Like you have a name. You have a name. They have numbers. That's the only thing. Like you have a name, they have a numbers. If they call, if they, in the class, if the teacher asks me, Balaji, do that, I will do that. In a company, if a manager asks me, Balaji, do that, Balaji will do that, not Ganesh will not do that. Or James will not do that. Like that, everybody is having a unique name in the system. How many names are possible depends on the address bit. If you have 16 lines, 2 power 16 is 65,536 or 64K combinations. This is a very, very simple concept. Somebody even asked yesterday how the hardware and software are connected. This is a simple. You call by a name and give it. This become hardware. This is software. Please understand. This is software. This become hardware. That's it. This one single line is converting your this line. Sorry, star out. 0, 1. This single line is converting your software to hardware because you are putting the address 8,000 because out is 8,000. You put 8,000. Since it's 8,000, this guy is selected. Which we already discussed. There is a small other unit is called select unit. That's called chip select unit. How that is? So there were three logics are there. One is called very simple combinational logic. One is called sequential logic. One is called tri-state logic. There were 3 gates are there. And, or, not. That's it. If you know this, you will understand thoroughly. Okay, that's as simple as this. But that is another technique, going from bottom to top. I'm coming totally different now. Try to understand this. This is what the important of 2022. You need to understand everything block level because every new company will come out with a new block, new device. If you say unless service, I know that I will not do that. Okay, then that's wrong. You should know how to start working with these details. With the given details, you should know how to produce the output. I'll give an address. I told you that if you write 9,000, if you write here 1, I will take 1 second. If you write 60, I'll give 60 seconds. Please understand that. That's why I told you. So totally how much? This one is having 255, 1 character. I define as a character. So this guy is having a 1 location, 8-bit. His maximum is 255. 0 means 0. Minimum is 0. So if I write here, start timer is equal to 60. Now you are writing 60 here. That's it. The moment you write 60 here, this timer start counting. The timer start counting. Now I'll say here, if while start timer equal to 0. Sorry, not equal to 0. Now you are reading. See, understand, you are reading now. The moment you return 60, you start counting down. The moment you start counting down. The moment you become a 0, you will put star out. It's equal to 0x1. You understand now? That is, you are watching the time. That means that you given a time to watch, but you are watching. This is called polling. This is called polling. Please understand the difference between the first one and second one. The first one, the delay was given by you. Now the delay was, but this is a very accurate delay. Whereas if you close your eyes and count 1, 2, 3, 4, that is not accurate delay. But whereas this is accurate delay. Then I will say once again, star timer equals 60. Understand? Now I'll do once again the while loop. So I will do this repeatedly. This gives you the perfect delay. This is called polling. But once again, I waste my time to poll. You, for example, you give a work to the employee. Okay, first you did the work. Now you given the work to the employee and ask the employee repeatedly, have you done the work? Does it look good? That you are wasting your time. You're wasting your time. Okay. So how do I avoid wasting the time? I told my employee very clearly, hey, I've given a work. Once you complete it, come and tell me. That's it. Or unable to complete, whatever it is. If you say that, if you say I cannot do this work, then come and tell me. For example, I asked him to take the 10 o'clock, take me to Bangalore from Chennai. He said when he went and checked the car does not have a petrol or some car repair. He can come and tell me that, sir, I've tried the car, but it's not working. Then I will do some other arrangement. Here, the same thing here. What I have done is quite simple is I am telling the controller, every controller is having an address and a name. Like you have a driver is having a name. You don't call somebody driver. You will call, hey, James, can you come? Salim, can you come? Sambat, can you come? You call them drivers by name. You never call by, hey, driver, come here. You know that. You don't do that. Like that here. We call everybody because sometime you may be having 5 drivers. Okay, you may be having 5 drivers. And that time you will call which driver you want. You call by name. See, please understand one thing. That name and this number are same. Don't get confused. Most people think that this is something different. Okay, there you are selecting a human being. Here you are selecting a chip. That's why they call this as a chip select address. Every address you are giving, okay, is having a unique person or a chip on the thing. That depends on input or output. If you write, it's output. If you read, there is an input. That's the only thing. Okay. So don't get confused with these addresses. Normally, everybody get confused as what is this 8,000, 9,000? Okay, that there is a box is there. The box will look for 8,000 and he will say yes. That is what exactly combination logic which we'll discuss during the combination logic. Right now, assuming that there's a block called select block. Now what happened? I told the timer to 9,000, sorry, start timer to 60. Now I've done. Now I never bother LED, I never bother anything. I'll start doing my other work. I'll start that scan, get input, do some other work. I will never bother about, see, now I have told the timer 60. He start decrementing now. But the moment he reaches 0, what he will do, now knocking the door in your servant. Now what this guy will do, there is a wire connected from the controller to the microprocessor. This wire is called interrupt. This wire is called interrupt. This normally this is 0 volt. That means that you will do your own work. The moment this guy becomes 0, he will stop counting. Then he will come and tell you 5 volt. The moment you get a 5 volt, what the microprocessor will do that, you are doing some work here. Now I'll write it here, slightly bigger one. Then you will understand. I'll say CHAR star out star timer. There are 2. I have 2 devices. This guy is 9,000. This guy is 8,000. I do now here star out equal to, sorry, star timer. Timer is equal to 9,000. Let me put 0x to understand that this is hexadecimal. I put star x is equal to, I'm putting 60. That means I'm writing 60 here. Line 1, line 2, line 3. Okay. Now I start doing I continue my work. Now I forget about LED. See that? I forget about LED. But maybe we'll start with, you can do the LED as on or off, but forget about now. Right now, let's not worry about now. So I'm doing this work. Suddenly, when I'm doing the 8th line, I'm doing 7th line. I'm doing the 7th line. That time, this guy completed 0. See that now 2 people are going parallelly. You are doing your work. He is doing his work. That is the advantage here. The controller. Controller is a separate intelligent device. That is not like a passive device. It's an intelligent device. That intelligent device is doing his own work. Now what happened? The controller gives 5 volt when you are doing the 7th line. Then what this microprocessor does, he remembers the 7th line. He remember I've done it 7. Okay, how it is remembered, we will discuss later in the C programming. That's a very nice thing. Don't worry about that. We are not discussed so many things. Right now, assuming that it's only a remembering. That's enough. No, he remembers the 7, not 7. 7 is completed. He will remember 8. Next line. He not remember the previous line. He remember next line. Now he know that he has to next line is 8. But he stops here. Suspense. He suspends the operation. He suspends the operation, your main work. Then, like when you're doing some work, somebody knock the door or you get a phone call. You will stop the work, you will say hello. Am I right? Like that. What that guy will do, he will go to the separate function. Please understand, there's a separate code is there. In that code, we have written char star out. Am I right? Now I know that when you come here, I say out is equal to 0x8000 because the LED is connected to 8000. Now you understand that. When I come here, that means that this guy becomes 0. Otherwise, I will not come here. So what will I do that? I will say star out equal to 0x01. But I don't know whether previously it's on or off. How do I do that? How do I know that it is previously on or off? Okay, that's a big problem. Okay, for that, it's a right now it's a small confusion, but we understand that. How do I know that whether previously bulb is on or off? Now we assume that if LED on, which I have to explain to you later. If LED on, then star out equal to 0x000. Else star out is equal to 1. Now you see here, what you have done here is, you put 8000, you put LED on, you put star out, and everything. Then you can tell him timer, start timer equal to 60. Once again, you give this to 60. Understand now? So he will once again start doing. But once I complete this may take about a few microseconds. Then I will come back to 8. I'll start continue my work. This is called ISR, Interrupt Service Routine. A separate small piece of code, which you will write it. Okay, the compiler knows where to put it. These are all compiler specific. We'll discuss later once you are good at C programming. When we are discussing about embedded system programming session, okay, next month, that time we'll discuss thoroughly about this. That time you will start writing program. I'll teach you on online code in such a way that you will be able to write a practice, like how you practice a C code now. You will start practicing the embedded system code. That time you will start knowing all these things very clearly. Now try to understand what this. That is what I want to know. That if you don't understand the top level, let me know. Now, once I finish the work, I'll come back. But there are some time I can tell the timer after making to 0. I given you 60. You start counting up to 0. Then once again restart from 60. So he will not. I need not have to rewrite once again. There are 2 modes. One mode is Every time I have to start the value, or next time, or otherwise he will do continuously. Once it becomes 0, he will once again start from 60. He remembers that. Once you write a number 60, once you write 60, he remembers. Sorry, not start timer. So I try to avoid the XY, so you'll be able to easily understand. So do you understand this concept of timer? Yes or no? Do you have, this is a very top level principle. That is, I have three way. One is I do myself, then polling, offload. Sorry, I can write like this. Outsource, polling, and third one is outsource, interrupt. This is called timers. This is an intelligent controller inside your microcontroller chip. This is some doubt somebody has asked. It's fine. So somebody has said they've understood. If somebody has not understood this, let me know. So this is a learn. See, you are all electronics people. Learn to try to understand the top level. If you do not understand the top level, then you have a problem to understand the very technical. Now there is another small trick is there here in this. You'll be very surprised. I can make this guy as a counter. I can make this guy as a counter. What will happen is you start with 0. You start with 0. Now there's a pin here. We connect a pin here. In this pin, if there's a pulse comes, he will increment by 1. Whenever there's a pulse comes, for example, you have a conveyor belt. You have a conveyor belt. In the conveyor belt, you have an object. When the conveyor moves, this object moves. Now, I have a light here and I have a light detector here. This, I have a small circuit and that goes and gives to this pin. Now, whenever the object crosses here, blocks, normally this is 0 volt. Whenever the object comes here, this becomes 5 volt. Then when the object crosses, it becomes 0 volt. So there's a small pulse will come. Now this guy will count. The same timer will count. But instead of counting a clock, now he'll be counting the pulse. Now it become 1. Now there's one more object has come. Second object will come 2. So whenever you go and read, you will know that how many. So if you say that car start timer, timer is equal to 0x9000. That is address. You put start timer equal to 0. You initialize with 0. Then after some time, you say x is equal to start timer. Assuming you have a printf. Assuming you have a printf %d, comma x. You will get to know that this value. If 5 object comes, you will get to know 5. Understand now? So this is, so that's why they always combine together. They call timer counter. That means if this guy is, there is a small clock generator here. That guy generates a clock for every 1 second, for example. That guy is generating every 1 second. And if this guy is decrementing every 1 second the count, then that is called timer. Then that is called timer. But you have an object coming out outside, and that guy is counting the pulse, then it's called counter. So it is another simple, intelligent microcontroller, but that's the operation of only timing and counting, nothing more than that. That's why they call that as a, this object is called timer controller. That is part of your That is part of your microcontroller. So as we said, microprocessor, ROM, RAM, output, input. RAM, ROM, no connection outside, they're only internally. And there is a controller. So they built in inside the microcontroller. One of the controller like that, like this, there are thousands of controllers are there in the market. For every activity today, what you have to do is you have to buy a right controller. You have to buy a right controller. You have to buy a right controller and start using that. That's the only thing. Let's say I want to control the motor. I buy a motor controller. Today, every company is putting the controller inside the microcontroller. Suppose you have a specific controller produced by somebody. There's a controller which is produced by somebody, which is not there in your microcontroller somewhere. Then you can do very easily. You can talk to outside world through I2C or SPI or CAN or UART and tap the controller. You do same thing. See, there's no difference between whether you do the internal controller or outside controller. Both are same. Both are same. The only difference is that guy is outside, this guy is inside. When you have an inside, you talk to them directly address. But when it's outside, you are using them through the I2C or SPI or CAN. That's the only thing. But the functionality, everything is similar. When we do the practical, we'll see that. Now let me close this theory in the very top level. You watch this video anytime, you should be able to understand what is called timer and counter. That's one of the simplest part in that. Okay, let me know if you have any doubts. Okay. Okay, then let me stop the recording.